Okay, so the data refreshing strategy is also one of the important topic. Usually, when it comes to data warehouse, we refresh the data, in two different way. One is we load it, the one-time data refresh. Other type is incremental data refresh. So one-time data refresh, for example, you are having a fact table, dimension tables. You design your data model, everything, and then what you do is you see the data warehousing is meant for storing the historical data. It's meant for storing the historical data. And what we do is we get the data from our operational system. This is my operational system. Let us say Flipkart. The Flipkart, in the Flipkart website, when you order any item, all these order related data, shipment related data, and inventory related, everything is getting stored in our operational transaction system, right? So OLTP, online transaction processing system. All the day-to-day transactions, everything will happen on this database. Hence, we call this a OLTP database. So what you want to do is you want to so in the OLTP system, we don't store the historical data. This I discussed as part of data modeling. Why we don't store the historical data in the online transaction processing system? Because it can cause severe performance. It can cause severe performance impact. Okay, this is my OLTP system. One second. Let me just. This is my OLTP online transaction processing. This is my data warehouse. In data warehousing system, we store the historical data. So what is a data warehouse? Data warehouse is non-volatile. It is non-volatile. It will consist of the historical data, and it will have the subject. It is subject oriented. It is subject oriented. Data is subject oriented, and it is historical, non-volatile. It is time variance. Okay. So this is what data warehouse. You store the historical data. So once you store the historical data, it will not undergo any changes. If you want to make any update or deletion on this historical data, for example, you want to store last 10 years data. 10 years data in your data warehouse. This is my data warehousing. The data warehousing, last 10 years of data I want to store it. The volume of the data is very, very high. When it comes to the Flipkart, all the e-commerce, let's take the e-commerce business, okay. So in that industry, right, the volume of the data is like anything. Every 1 hour, approximately 1 million transactions are happening. For example, hypothetically, right, let's say 10 hours per day, right? So 10 million per day, 10 million records are getting, generated every day, right? So every day, daily load. We have some daily load, weekly load, and intraday load. Same day, 2 or 3 times the data will get pushed from your OLTP system to data warehousing. Why? We want to store the history here. A customer ordered, and later point in time he changed or updated the order, or sometimes some cases the customer cancelled the order. We wanted to know all these things, and also we change the price for different product at different period of time. We wanted to know all these details, historical details. So when for so and so period, what is the price, what is the price for specific products, and with this price for the same product with different period of time with different price, what is the sales. If you want to do some kind of analysis, you need to have the historical data. So you store the historical data. Since you store the historical data, the volume of the data is very, very, very high. Sometimes it will be close to petabytes volume of data it will have in it. Since the volume of the data is very high, and if you try to delete or update, it will cause severe performance issues. So it is not advisable once you store the historical data in your data warehouse, right? So don't do update or deletion. And also it is subject oriented. In the data warehouse, you store for different subject areas, right? We store the data here. For example, supply chain analytics, you will have a separate schema, and you have another schema for the inventory. Likewise, for different the line of business or different department will have different subject areas, and it's time variant. Okay, for you will store the data with time data, because time based analysis you will be doing it year on year sales analysis, like for like analysis. If you want to do it year on year, quarter on quarter analysis, you need to do it. So right, so if you store the data along with the date, everything, right, so in that case it is pretty much helpful to do exhaustive analysis. So that is the whole idea of storing the historical data in data warehousing. Now we understood what is the characteristics of data warehouse, right? You are not supposed to make any changes on there. So some cases we load the data on a daily basis. Let's say you have created a database, you built the data warehouse recently, and you wanted to migrate all the data, right? So in your system, let's say you have another system, right? You have mirrored all this data into another database, right? So temporarily, right? So as and when any record comes, you don't want to store the historical data here, because if you store it, it'll have huge volume of data in it. Hence it will cause some performance issue. Hence you don't want to store the historical data in the OLTP system. Instead you copied the history data in some other systems temporarily. So now you want to create a full blown data warehouse wherein you want to copy all the data. For example, I have the sales, my table name is fact sales. Okay, I created a fact sales that is available in my data warehouse. What I do is, since we have launched the data warehouse by 2021 year end, 31st December 2021, okay, and we have launched our data warehouse. So what we did, we store the 10 years data. 10 years data are available here in the temporary storage system or somewhere. What you are doing is you are doing one time load. You are doing one time load. So what you are doing is you are doing one time data refresh. All the 10-year data, on 31st December 2021, you are loading it into fact sales. This is called one time load. Okay, 31st December 2021, I loaded the data. So after this day, right, 31st December 2021, if any data comes in, how will I load it here? That is called your incremental data refresh. If any record get changed, okay, if any record get changed, if any existing record get changed, or if any new record get inserted, here in my source system, let's I have in the sales transaction file is there. In my source system also I have a transaction file or table, sales transaction table is there. As and when the customers order anything, it will get recorded here. Any new order gets stored here, that one should get refreshed to my data warehouse fact sales also. Daily transaction should also get refreshed here. There are different types of fact tables. Let us assume that the fact sales is also the transactional fact table. It will record all the transaction related, right, everyday transaction in this fact table. Every day it should get. Okay, so 31st December 2021, as on 31st 2021, right? So let's say 10 years, if you divide 2011 to 2021, right, 10 years data, you load it once into fact tables, one time refresh. You remember in my dash, this one, I can go to any of the one here, any of the workspaces. If you go here, so this is my report. Along with each report, the corresponding data set will also get published automatically. So you have an icon called refresh now. Another icon is schedule refresh here. This is one time refresh. When you click on it, the entire data from your on-premises, from your laptop to cloud will get refreshed. Let's say in our case, we have 10-year data is there. If you click this one, what will happen? This one. This is on demand, right? So when you click on it, the entire data will get pushed. 2011 to 2021 will get pushed to fact sales. You see, to push this one, it takes hell lot of time, right? So it takes a lot of time. It takes 3 days time or something like that. Okay, you have you have an expensive server, you have a cloud, everything is there, and you are using expensive resources, but still it takes 3 days time. Okay, your resource, whatever the resource that you use, it's all scalable, everything is good, but still the volume of the data is very high, hence it takes 3 days time. This is my full refresh. Full refresh. This is called my full refresh. Okay, everything is done. Okay, so it took 3 days time. One time data refresh has been done in my fact sales, and first Jan 22, right? From this is my last refresh date. This is my last refresh date. Remember this, okay? 10 years, one time refresh, one time data refresh, and this is my last refresh date. Anything after this date, any record comes after this date, is considered as a incremental refresh. Okay, so instead of loading 10-year data for example, 1st January, 100 customers they ordered, 100 records came in newly, right? 100 records got inserted into my OLTP system sales table. These 100 records should also get pushed to my data warehouse fact sales table. In the data warehouse we have fact sales table, it should push the 100 newly inserted records also from the OLTP to this one. Inserting 100 records will not take much time. What if situation wherein, right, you don't have incremental strategy? So if you refresh it every now by clicking this icon, what will happen? It will every day when you click, see, up to 31st you took 3 days time to load it, right? After taking a lot of pain, right, data got loaded, 10-year data. And just because after this fact tables was 10 years worth of data in it, and 1st January onwards, right, 22, 100 records, in this case 100 record, only 100 record has to be inserted. But when you click on this icon, what will happen? When you click on this, what will happen? It will just to load 100 records into my fact sales, I need to append this 100 records along with the 10 years data, isn't it? Appending 100 records to the pre-existing data is much simpler task. Rather, if you refresh it, when you click on the refresh, what will happen is it will load the 10-year data along with this one on a daily basis. If you schedule it, right, if you don't schedule the incremental refresh, what will happen is it will load every day the entire data. We don't want to load the entire data on a daily basis. Already we did the one-time load, so 10 years data we loaded it. On a daily basis, on an incremental basis, we want to insert the data on a daily basis. 100 records, if you insert it on a daily basis, it will not take much time, right? Okay, so that is what incremental refresh is all about at the high level. The incremental refresh was available only in premium capacities in the previous version of Power BI. But from February 2020 onwards, I think so, okay, it is supported in the Pro license also. If you have bought the Pro license, right, so you can still enable the incremental refresh. Okay, the incremental refresh is nothing but incremental data loading. Okay. So, okay, so now you understood what is the difference between one-time data refresh and incremental data refresh. First time you are setting up the data warehouse. In that case, all the data you stored for the last 10 years from your tape or some other backup system, right? So you take that and load it once in your fact sales. So this fact sales has 10 years of data in it. And then on an incremental basis or daily basis or weekly basis, you will load the data to the existing fact sales table. Okay, let's in this case, right, incremental data refresh can be daily, it can be intraday, or it can be real time, near real time data refresh, and it can be monthly also, okay, and quarterly also, right? Some certain reports, right? Every quarter you wanted to generate some report. For that, every quarter only we will load the data. But the idea is this one. So on a daily basis, right? If you load 10 years data, along with this, if you load today's data, let's say today 100 records got loaded. So every day, if you load these two things together into fact sales, it will take a lot of time. Once you store the 10 years data into this one, refresh it, and on an incremental basis, you load the daily data to this one. Let's take for example daily data refresh. Okay, so daily data refresh, how it is possible? For example, you know very well the last refresh date. Let's say the last refresh date is, let us assume that today is 12th March, right? So up to 11th March, the last refresh date, up to 11th March, you loaded the data. Anything beyond last refresh date, right? That means those records you need to refresh it into your fact sales. For example, today is, let's 10th March. Up to 10th March, you loaded the data. Okay, every day by 6 p.m. Evening, we need to load the incremental data into my fact sales. This fact sales already has 10 years data. I don't want to reload it on a daily basis. Okay, so let's say today 11th March by 6 p.m. right? So it has to compare. Okay, so last refresh date is 10th, and after 10th, right? So today is 11th March. Between 10th to 11th March, whatever data is there in your OLTP system, you need to refresh it into your data warehouse fact sales table. It is as simple as that. This is called incremental refresh. Okay, so now the question is, how is it possible? So we have something called last refresh date. Let's say we are storing somewhere 10th March 2022, and 11th March, how the system can understand the new record needs to be pulled in from your source system, OLTP. This is my source system, right? So how? So what we do is, in the case of RDBMS, each table, for example, the sales table, this is there in my OLTP system. In the sales table, in addition to the business columns like order date, order number, customer ID, customer name, quantity, all these things, right? In addition to that, we will have some audit column. Each table will have last update time. Whenever new record get inserted into my OLTP system, you just think in the Flipkart site you are ordering it, that data will get inserted in your order, and like you multiple users they ordered. Let's say 100 orders got raised today. Whenever new record get inserted into this OLTP system sales table, it will, along with the record, it will show the last update time also. Let's say yesterday 100 records got inserted, so this one will also have 10th March. I'll just write it neatly here, 10th March 2022. It will have 10th March 22 in it. So last updated time, this one. Last refresh date is different. Last update time, let's say my last update time, what is this? 10/3. The month date here, 10 March 10 2022. So this one, what is this? This is the one is this is up to yesterday. Okay, and today. Okay, last updated time is, so today 100 records got inserted into my source system OLTP table sales, and last refresh date is 10th March 03/10/2022. Okay, so this one, now we will compare. If my last update time is greater than the last refresh date, then you push the data to fact sales. So in between these two dates, whatever data got stored, up to the 310 we store, we loaded the data, and 310 to or greater than, greater than 310 to and 311, whatever the data is there in between in your sales table, only that data you need to refresh it in my fact sales. In addition to the data already I have it, right? So in addition to that, you load only these 100 records or so to my fact sales. But the one-time data refresh, what we do is we truncate and load. We make sure that we are not going to truncate and load. First time when you load, you delete the data in this table to avoid confusion, and then you load the 10 years data. In our case, we are talking about 10 years data. 10 years data, once you loaded it, in addition to that, on a day-to-day basis, you need to, on an incremental basis, day-to-day basis, you need to load the data into my fact sales. So that when you see at the end of this year, 31st December 2022, so overall you will have 11-year data in it. Again, we will set up some kind of rolling rolling window, right? So 1 year rolling window archive strategy, something like at any given point in time, only 10 years worth of data should be there in this fact sales. What is rolling 1 year or rolling year, right? So rolling year, right? So rolling 1 year, 1 year archive strategy. So archive strategy. That means at any given point in time, only 10-year data should be there. Now you might be asking that by 31st December 2022, we will have 11-year data. So in that case, what the system will do is the previous one, right, 2011 data will get backed up and it will get removed from your fact sales automatically. That one will get archived, okay? That's all. So that is what rolling 1 year archive strategy, okay? You understood the difference between one-time data refresh and the incremental data refresh. So now we will go and see how to do it in Power BI. It will take some time. What we will do is we will carry forward this tomorrow, the demo session. Usually in the source system table, OLTP source system, right, almost all the tables, there is a column called last update time will be there. Maybe the column name will be different. Along with the business columns, this column will be there. Here they will store the date, the inserted. For example, today you ordered 100 records, right? 100 orders. You and other people, 100 orders, we received it. Along with that, order number and other details in this column, today's date will get, stored, right? So if you find anything, right, latest in this one, how do you know that the incremental data? How do you extract the incremental data? So you know until yesterday we loaded the data, right? 310. So anything, if the last updated date time is greater than this one, that means, right, so anything beyond 10th March, if it is there in this table, extract only that record and load it into this one. It is as simple as that, okay? So for that we have 3 or 4 steps are there to configure the incremental data refresh, right? To define that policy, 3 or 4 steps are there. We will discuss it tomorrow with the demo. I will show you. I will show it with my Excel file, and with that you understand how to define a policy also, and then you try with some tables in SQL Server, okay, and see how it works, okay? And then followed by that we will continue with DAX tomorrow. We'll start with the DAX, okay? Any questions so far? Okay, since you don't have any questions, I'm going to